Morning, everyone. With that amount of videos about JP Morgan, no pressure doing this today. So, as I said, my name is Steve, and I'm here to talk a little bit about how we're using modern web technologies at JP. Things like ES modules, where we can use them to solve kind of age-old problems. Problems like how do we run multiple applications that have all been built and deployed independently of each other in single container portal-like applications. So a little bit about me. I've been working in and around the fintech space for about 20 years now. And I've had the privilege to see UI technologies grow during that time. Now that I'm with JP Morgan, I'm no longer a core developer, but now I get to work with developers to put together our open source providing we have two things that I'm going to talk about today. One is the UITK, which is a React component library that we use to standardize the way that our applications look and feel. And Modular, which is an opinionated monorepo management tool. And they're actually both on our public GitHub if you want to check them out. And we appreciate pull requests. The kind of places that I've worked at before, I said it's always in fintech. Some of those organizations are really small. And when I came to JP Morgan last year, I had no real idea of a sense of scale that I was going to be facing. We have, across the bank as a whole, is 50,000 developers, I think, 18,000 of which are in our division, and they're deploying about 5,800 applications into one of our container types, which is a desktop container. 2,000 of those are in production. They service about 200,000 daily users, and there's hundreds of deployments going on every day. So obviously we have this really distributed development problem, or joy, depending on how you look at it. Because distributed development means that we've got loads of development teams. They all work independently. They're empowered to make their own choices about how they're going to build their applications, how they're going to deploy them, and more recently, how often do they deploy? Why are they actually sending code out? But looking at it from an organizational standpoint, what is the developer experience of that distributed development model? Well, every development team has to solve the same problems. They're all going to need to have some form of continuous integration. They're all going to need continuous deployment. And they're all going to have the same need to apply quality assurance. So they're going to need test tooling. They're going to need to choose the same products for doing their testing. And then because we're all under the same brand umbrella, we're going to need to have the same design language. So how do we add that consistency to the applications that we're deploying, bearing in mind there's thousands of them being pushed out? So when the applications go out as well, they're going to need to solve the same kind of problems. We need to know how they're going to authenticate their users, how will they authorize them to use the apps. And because we want to have the same rich user experiences, we're thinking, how are you going to be able to share the layouts you've created? How are you going to share access to your applications? Which all kind of implies that you've got the same kind of understanding of having a preferences system, how you're going to store and persist the user data. So what was our solution to that? So our solution is in UI engineering. We have what we call the digital platform, which is a bit like a Jamstack provider inside the bank. So I've already mentioned we have a desktop container, but we have ways that we distribute our mobile and web apps as well. We call it omni-channel. But we also provide more of a DevOps providing. So we have things like continuous integration. Actually, it's based on Jenkins. We have continuous deployment, which is based on Amazon S3. And we also provide a centralized application registry. And that's where we have our developers push their versions of their code so we can determine which are going to be made available in production. And more importantly, when we need to roll things back, it simplifies our processes. And then probably more relevant to today, and what I'm going to be talking about later, is we have a design system. So that is it's an accessibility-first design system that has a companion React-based component library. We had been embracing web components and allowed for the use of Angular. There was a decision made a couple of years ago that we were going to be React focused. So we actually have a new version of the React library being developed at the moment. It'll be released fairly soon. Feel free to go and have a look at it on our GitHub. And then finally, the modular, which is our opinionated monorepo management tool. It has a few features in it that I'll be showing today, but it's similar to Create React App, and then an opinionation on developer tooling that goes in with building the applications themselves. So we have a desktop container. The developers, when they create applications, push it through to our continuous deployment infrastructure and tell the desktop container, which is an Electron-based app, where to fetch the URLs. When we come to deliver a web portal, what is the user experience expectation? It's almost the same as on desktop. Users still want to have a single way of launching applications. They want to have a consistent look and feel on the apps that they're loading. And they want to be able to use their apps in all modern browsers. So historically, that could have meant using iframes to load applications together, which would come with this usual drawbacks of you've got potentially many instances of frameworks being loaded into one application, into one web browser window. The use of memory, things get janky. You can't share or readily share CSS and theming between the various apps that you've loaded. So what was our solution? Well, I mentioned that we're using modern technologies, so now we are focusing on having micro-frontends. The micro-frontends that we're looking at are relying on ES modules for splitting the applications and loading them dynamically, and the React library that we've created uses CSS variables to share theming across the various apps that you might be loading. It comes with many benefits, things like if you're using ES modules, the way that we will be transpiling our applications is we take the source code, usually in TypeScript, rewrite imports that are in your own application to bundle your application code separately, and then rewrite all of your external dependencies onto a CDN. We use an open source CDN for ES modules, esm.sh. Have a look, it's great. But you may also be using Skypack, and we actually have internal versions of these that are able to access and transpile our existing Commons.js node modules in our internal registry into ES modules. In case you're not familiar, ES modules are a modern standard of creating JavaScript in its simplest form. You're probably already using them in TypeScript, and it's a convenient way of just simply having your imports and exports in your code after it's been transpiled to JavaScript. The other thing is that we have a web application container. We dropped support for Internet Explorer in the last year or so. We don't really mourn its loss because it does mean that we're able to use evergreen browsers now, all of which are able to support dynamic loading of imports in JavaScript without any need for any plugins. Okay, so building a micro-frontend. That was lots of words from me. It's live demo time, which obviously never goes wrong, so please bear with me. I've mentioned, I've mentioned modular. It does have a way of scaffolding applications. It's based very similar on Create React App. However, what we're looking at here, I'm going to use this is a minimal monorepo. It has a couple of packages in so far. One package is simply an Express server that's mocking out the application registry that I talked about before. Is going to serve up our built content so you can see the demo. And we also have an example of how you would create a host app. Now, Create React App would be able to serve these components, so it looks very similar to normal, using Webpack, so Webpack and Webpack Dev Server. Recently, we switched up to Webpack 5 and added support for ES Build. With ES Build, instead of generating a Commons.js bundle, we're now creating an ES module bundle. So all I'm going to do in here is run a quick command to, to start up as an Express server. It's also going to start Webpack Dev Server that builds this host application. And it should, there we go. Good. It's going to very slowly load on localhost my application. We'll just assume that that's the case. I'll come back to it. Thereafter, other things that modular has in it. Now, I mentioned this delivering of development at scale. At scale, we often have the need to create new applications, and those new applications are created from templates. So modular has a feature that can either use templates based on that come directly from NPM or from within your repository. So I'm going to use them that are coming from my repository. So I'm going to add a new module into my monorepo. I'm going to look at the card. I am. There we go. Said can't type with people watching me. So running a modular command to add a new package into my template. I've created some templates already, but just so you can see how they get added in. Why am I running through this? The templates that we add are actually, they can all be run as independent applications. So in the code view, I've now got a new application. It doesn't do an awful lot. Fortunately, it doesn't use React, use effect rather. Oh, it does. Oh. Is that an effective one? Maybe. Okay, so pretend you haven't seen my use effects. I did say that I don't do code for a living anymore. And now that that's created a new package, I can actually start this for myself. So I'm going to start using a new port. Okay. So let's say that I'm going to just run this application. So what this is proxying is if a developer is creating the app for themselves, then did the old one load?
Steve,
hello.
Can you get the font size, please?
There we go. These do load. Oh well. If it doesn't load, I'm just going to talk for a little bit longer and then show you the video, because live demos do that. Good. Anyway, assume that you can render those. Never mind. 3000, 3001. You know, I've never seen Create React app just stop. Good, I knew I shouldn't have tried to do a live demo. Okay, so I'll carry on for now, and then I'll show you the video, and it'll be amazing. I'm going to add another one. Okay, so trying again. The next, I'm going to have to just talk. Does it start? Good. Good. Who would want it to just work straight out of the box, eh? So, never mind. Good, yeah. Okay, so what am I going to talk about? The idea is we have this card view. They actually get rendered as independent applications that you can that you can start with Webpack Dev Server. The next up is having created a couple of packages that I can show them running together. So next I would need to build them. Now, the difference in the build process is that by running through ES-build, we are... By running through ES-build, we actually create an ES module, which is a single file that can then be pushed onto a CDN. In the example I have here, it actually runs as a local server. And let's just see if it's magicked its way through the internet. Turns out I'm not online. That's a shame, because I've styled it since I created this video. Disappointing. Oh well, you get to see what I was doing yesterday. So, assume that this is running live. I'm going to see why my modules aren't fetching from the internet, and maybe if you come find me, I can show you a real running version of this, as you can get from all the videos. We have a stand out the front. I'll be there later with a working version. But I'm going to show you the mocked-up version instead. So here we've got the same code window where I did a yarn serve. This was going to start my node server, which is like the proxy for our app registry, and sets up a create React app. There's nothing on the screen so far, because what I need to do is add one of those components. So this is showing you how I built one of those, runs through ES-build. By running through ES-build, generate my ES module. That then gets stuck on the CDN. You can see here, if we have fetched it using our portal, actually, that's something I can show you. This is a JavaScript file that gets loaded dynamically. How did we do that? In the host package, I created a remote view. The remote view it's a very simple component that just fetches a module from a URL. That module, obviously, it shares its state through a context to ensure that we don't try and load these modules multiple times. But here you can see how we're actually loading the remote view. That loading it's all JavaScript that runs natively in the browser. We don't need any plugins to do this. We simply have fetch from our manifest. We use package.json to define the content that describes the module. We use that, actually I can show you one of those, we use that to describe how the module has been built. So you can see including some packages, that's our design system, but also where is the output of the JavaScript and the CSS. Those are then going to be used by this remote view to say, when we fetch that package.json, then we know if we've got a style sheet, we can insert it to the HTML. That may not be the best way of doing it, but it worked. And if we have a manifest, now this one is where we've put the JavaScript. So see that dynamic import, that is natively supported in all browsers. If you are running this through Webpack, you'll need a little escape hatch, because Webpack will try and evaluate that import statement for you. But knowing that we've done a dynamic import in the browser, that actually gives us the evaluated default content of the package itself. So we know that those are going to be views for us. So we simply use that view as a component constructor and can include it in the TypeScript TSX. I'm presuming I still haven't gone online. OK, so the next bit is I can add more. Components into this, independently building them from each other, and then we can use the portal, simply because it does dynamic loading. The portal is deployed independently of the applications that it contains, and then they can actually, in my real working demo, I was so proud, I have the grid and the card talking to each other. But there we go. There is an example that I can share that shows this running. It is a very simple thing to get up and running. I think that was me approaching time. There was left for me to say that we have, by loading the modules into the same React tree, we can benefit from things like sharing of modules, sharing of dependencies, especially if you've got stateful dependencies. They actually share the same instance. So we do have a system of recommending that our app developers pin at least React to the same version, which simply just uses the resolutions object in a package.json, that we then use the same React version across all of our applications. And yeah, so our builds are faster because we only have to actually build and transpile our own application code. They reduce the file size that we're storing on our CDN. They load faster in the browser because they share dependencies between them. And yeah, I'm really excited that we get to use modern technology to solve problems that have been around for a long time. So apologies that the demo didn't work quite well, but honestly, come see me later, and it does actually work.